When a charged particle accelerates, the electric field it produces is suddenly shifted, and the kink that results moves through space at the speed of light. We call this kink light. The kink also generates a magnetic field, and the magnetic and electric fields interact with one another. It is for this reason we call light an electromagnetic wave. The simplest electromagnetic wave to think about is that produced by a charge that is oscillating back and forth with time at a single frequency. The frequency of oscillation is set by the top slider. The units of frequency are hertz, or oscillations per second. As you can see from the scientific notation, the initial frequency here is very, very high. The highest frequency light is known as gamma ray light. The wavelength of the light produced is about the size of a nucleus. And in fact, gamma rays are often released in nuclear reactions, such as the fission of a nucleus into smaller bits. The range over which the frequency of light can vary is very, very large, so we divide up this range into arbitrary bands. Gamma ray is the highest frequency band, and the wavelengths extend to as small as physically possible. As we move downward in frequency, we pass through other wavelength bands. X-rays are lower frequency, and so they have longer wavelengths, about the size of an atom. Ultraviolet light is about the size of a molecule. This is part of the explanation for why UV radiation can damage DNA molecules in your skin. Visible light is about the size of a bacterium. Infrared light is about the size of the eye of a needle. Microwaves are the size of a small butterfly. This is why many microwave ovens have a way to rotate the food, and why you should let your food sit for a bit after it cooks. Otherwise, you'll get hot and cold spots in the food separated by about the size of a butterfly. Radio waves are the size of people and larger. You might have noticed that radio antennas are about a meter long, like the ones you see on cars. This animation, when you hit play, shows the electric field oscillating up and down, and a magnetic field oscillating side to side. This is typical for electromagnetic fields. The electric and magnetic fields are at right angles to one another. The orientation of the plane of the electric field describes the polarization of the light. Here, the light is linearly polarized. If the plane of the electric field rotates with time, we might describe the polarization as circular or even elliptical. So play around, and thank you for watching.